Okay, so we have question 6. It says on 31 January 2020, Tsepo made the first of his monthly deposits of 1,000 into a savings account. He continues to make monthly deposits of 1,000 at the end of each month up until 31 January 2032. The interest rate was fixed at 7.5% per annum compounded monthly. Then 6.1.1 says, what will the investment be worth immediately after the last deposit? Right, so we are talking about an investment. We know the formula that we are supposed to use here is F, right? But then looking at what else are we given, we are given the interest rate 7.5%. Then the period is from 31 January 2020 to 31 January 2032. So because this is from January to January, we know that from 2020 to 2032, that's 12 years in between. Then multiply by 12, we have 144. But then because this is starting from January and then ending at January, that means we'll be adding another month here, which will give us 145 months, because we know a year is from January to December, right? But then from here you can see that it starts making the payments on 31 January, which is end of January, and then completes the payment at the end of January of 2032. So if you count all those months in between, that's exactly 145 months. So now, having to tackle 6.1.1, we have our monthly deposits of 1,000 here. So substitute 1,000. And then we have 1 plus the interest rate is 7.5, so we write it as 0.75 over 12 compounded monthly. But then how many months do we have? It's 145 months. Then that minus 1 over 0.075 over 12. So if you punch all this in your calculator, you have 234,888.53, right? So that's your solution. Now 6.1.2 says if he makes no further payments but leaves the money in the account, how much money will be in the account on 31 January 2033? So in other words, if he leaves the money for 12 months, right? So for 12 months, it doesn't withdraw the money. So this is a case whereby now we are taking that investment amount and then we are putting it as a lump sum here, right? And then leave it in the bank, leave it in that account so that it grows on itself. So we are no longer making the fixed deposits or the monthly deposits. So now the formula that we have to use for this one is the compound formula, which is A is equals to P 1 plus I to the exponent of N. Then remember, the principal amount now will be the value of the investment after those 12 years or after those 145 months, right? So now, having to deal with this one, we have that one 2, 3, 4, 100, 888.53. So 234,888.53, and then 1 plus the interest is still the same, 0.05 over 12. But then how many months is that? 1 year, it's only 12 months, right? Then if we calculate here, 253,123.44, right? 0.54. So it's 0.54. Now 6.2 says Jim bought a new car for 250,000. The value of the car depreciated at a rate of 22% per annum annually according to the reducing balance method. After how many years will its book value be? 92,537.64. So he bought the car at this price, and then now they're asking after how many years will its book value be this. So we need to calculate using the reducing balance method, which goes A is equals to P 1 minus I to the exponent of N. So we are looking for this N here. So what do we have? We have A is 92,537.64 and then the principal amount, which is the value in which you bought the car those years back, 1 minus 0.22%, and then we are looking for n. So if we are looking for n, we have to make use of our log rule. So this is log, and then take all that as base 0.22, and then now we have to say 92,537.64 over 250,000, right? So if you punch all that in your calculator, you have your n, and then it gives you 4. Right. Okay, so we have 6.3. It says Mpho is granted a loan under the following conditions. The interest rate is 11.3% per annum compounded monthly. The period of the loan is 6 years. And then since it's compounded monthly, we can just write this 6 years in terms of months. That's 6 times 12. And then that gives us 72 months. And then the monthly repayments on the loan is 1,500. Her first repayment is made 1 month after the loan is granted. Now 6.3.1 says calculate the value of the loan. So what is the value of the loan? It is obviously the present value. So for this one, we have to use the present value formula. So the monthly repayments, we've been told it's 1,005, and then we have 1 plus the interest 11.3, we can write it as 0.113 over 12 because it's compounded monthly. And then how many months? Said it's 72. Then all over 0.113 over 12. So if you punch all this in your calculator, the solution that you have is 78,173.49. Right, so that is the value of the loan. 6.3.2 says how much interest will Mpho pay in total over the first 5 years. So over the first 5 years. Now what we need to do with this one is first, let's present all this in a number line. So from T0 to T72, that's 6 years. But then here we are only asked about 5 years, so that's up to T60. So 60 months is 5 years. So now we are looking for the interest that it will have to pay for the 5 years here. So in order to get that, one thing that we need to find is the amount that he has to pay within that 5 years, right? But then to find that amount, we need the outstanding balance here, right? So the outstanding balance will tell us the amount that he needs to pay off to complete the loan. Calculating the outstanding balance first, we know that we have, and then our monthly repayments still the same. Then 1 plus 0.113 over 12. Then here, remember from T60 to T72, how many months in between? That's 12 months because that's 1 year, only 1 year. Then over 0.113 over 12. So that should give us 16,945.00629. So I'm avoiding to round off because I haven't reached the final answer. Then from this, we can get that this is the outstanding balance here. So let's write it here, 00629. So this is the amount left to be repaid for this remaining 12 months. Then, but we know the total value of the loan. We calculated it previously. It's 78,173.49. Now, in order to find this amount here, let's call it Y. In order to find this amount here, we can just take the total value of the loan and then subtract it by the outstanding balance. So to find the value here, the present value for first 5 years, we just have to say 78,173.49 minus the outstanding balance 16,945.00629. So having to calculate here, we have our solution as 61,228.48, right? Okay, but then remember, in order to calculate our interest for a loan, we have to have nx minus the present value. We have already calculated the present value. That's the 61,228.48. Now we want the total amount repaid over that period of 5 years. So total amount paid over 5 years. So to get that one, we say 5 years is the same as saying 5 times 12, and then multiply that by the repayment amount, or the regular payments, which is 1,005, and then that should lend us to 90,000, right? So we have 90,000. Now to calculate the interest, we already have everything that we need, which is this nx 90,000 minus the present value for the 5 years. So it's minus 61,228.48. Now if we subtract the 2, the solution that we have is 28,771.52, and that will be the interest repaid, or the interest paid over those 5 years.